any parties or function, there only we are going to be using here a speakers, amplifier, mic, like that. So everything should be there. There, by using the amplifier, you can able to increase the volume, increase the bass, and reduce the treble or increase the treble, okay, volume or whatever it may be. That should be getting by using that instrument. That instrument is nothing but a amplifier. So amplifier which can amplifies the signal here. That means which can enhance the signal here. Okay. So that is nothing but a amplifier here. So here feedback, what is a feedback here? So one thing you have to know about that, whatever it may be, when you are going to be sending a signal inputs, at input you need only two terminals, and by that instrument, if you sending, that output is also to be considered as a two terminals. So that input is to output is to, total is four terminals which is to be needed here. Okay. So whenever if you send a signal through the amplifier, and that's the amplifier which is to be amplifying the signal here. So indirectly you have to imagine that the strength is going to be varies here. The strength is going to be enhanced by this instrument here. So that the output, there should be a strengthened signal which is to be considered, which is to be getting here. So what the output, a fraction of the output, whether it is a voltage or current, whatever it may be, the fraction of the output which is connected to the input here. Okay. Then you have to say that the setup which is nothing but a feedback. Okay. Feedback. So here, if the strength of this signal at input, when you are going to be here feedbacking by using the feedback circuit, and here amplifier, what is the gain of the amplifier here? The output voltage by the ratio of the output voltage to the input voltage is nothing but a gain of the amplifier. So A equals to gain is, which is to be here denoting a term is capital A. A equals to V naught. V naught means output voltage divided by VI. VI is nothing but input voltage. The ratio of the output voltage to the input voltage is nothing but a gain of the amplifier. Okay. So, and that output voltage, a fraction which is to be connected to the input here by using a feedback circuit, that is a nothing but a beta. Okay. So beta equals to feedback circuit, beta equals to ABI. Okay. So that here which is to be connected to the input here. So the thing is that here, when the strength of the input signal which is greatly increases, that is nothing but a positive feedback. Or else the strength of the signal that is positive is regenerative. And here the strength of the signal which is to be minimized when the feedback is to be takes place, then that type of feedback you can call it as a negative feedback. So I just want to show you here what is the circuits for the feedback, and these are the combinations which is to be a resonant circuit which can consider it as a combination. Okay. So here 1 volt, 2 volt, 3 volt, that is to be capacitor. LC combination is there. Two capacitors are there which are in series, and which is to be here parallel. So that is the two combinations of capacitors, and one inductor is there. And other circuit which can consider it as a two inductors are there, only single capacitor is there. So like that you can able to build up the resonant circuits here. Next, what is the feedback? Positive feedback, and how you will get the here which should be considered as a here oscillator. So you can easily see that diagram which consists of here the input is there, the cross mark which is to be indicating that is nothing but a signal here, a cross mark, and A is nothing but a gain of the amplifier, that is the amplifier is there, and output which can consider it as a V naught is a output voltage. Again the output voltage which is connected to the signal input. You see that? You see that here? Okay, the output, a fraction of the output which is to be connected to the input here. So that should be possible. One circuit consists of the here a transistor, resistors like that. Okay. So that is to be denoting a here not a B, that is a beta. Beta. Okay. A is the amplifier gain of the amplifier V naught by Vi, and beta is the here gain of the feedback amplifier. So the gain of the feedback amplifier, which is nothing but a here Vi equals to beta AVI. Okay. So that you can easily consider that. So the feedback voltage which is to be considered, if it is to be greatly enhanced, then that is nothing but a here a positive feedback. If it is to be reducing the input voltage, that is a signal. When you are to be feedbacking the output voltage to the input, then that is nothing but a negative feedback. You can easily, we have to draw this. And one more thing here, beta V naught equals to beta into AVI. So what are the conditions? You have to do this. What are the Barkhasan criteria? So what is the Barkhasan criteria? A beta equals to 1. A means gain of the amplifier, beta is the here the gain of the feedback circuit here beta. So that A equals to, if it is 1, then the feedback circuit which is to be acting like in this condition only, the feedback circuit which is to be converting into the DC into the a pulsating AC. So that what is the criteria here to do the oscillations? Okay. So when you send a signal, AC signal, so how it here which can convert into RLC, which is to be act like an oscillator. Oscillator means which is to be oscillate with such a frequency here. Okay. So here which can gives the output as a voltage or whatever it may be. So the criteria is A beta equals to 1. You have to show like this. Next, RC oscillators. Next one is the R and C. What is R? R is the resistor, C is the capacitor. So RC combination. So in this RC combination, there is a 2 stages are there. One is the here a single stage RC coupled amplifier, and coupled. You are going to be says that coupled, and another one is which is consist of a 2 stage RC coupled, multi-stage RC coupled amplifier. So in this you have to say that here what is R and C combination. So here R and C combination which can here you can easily hear that audible range here. Okay, the frequency you can easily hear that. What is the RC coupled amplifier which consists of Wayne bridge oscillator? There only we are using RC combination, resistor and capacitor combinations, and another one is that here phase shift oscillator. Okay, Wayne bridge and phase shift oscillator which can have R and C combinations. Okay, that is here you can easily hear the frequency here. Next one is the radio frequency. There you can have a Colpitt's oscillator, Hartley oscillator, like that only. There only we are using L and C combination. L means inductor and C means capacitor. These combinations we have to be using. So this question is asked so many times, so many. Wayne bridge oscillator. Wayne bridge oscillator, you have 2 impedances. One is that op-amp operational amplifier is there, and output how the feedback is to be takes place. You can easily observe from the figure here. Z1 here, capacitor C and R combination is there, and Z2 here there is in Z1 there is a series combination. In Z2 there is a parallel combination of R and C combination is there. Okay. So feedback amplifier is also there, the output fraction which is connected to the input. Okay. So there you can derive the equation for the what is the impedance and what is the feedback here circuit gain here. That is to be showing that when beta into A beta value, if it is 3, it is to start the oscillations here. Okay. So the condition for the maintenance of the oscillator, which is nothing but R1 equals to 2R2. Okay. This is wrongly typed, mistaken here. In between there is a equals to is there. R1 is equals to 2R2, not R1 2R2. Okay. So you can follow that. Next, phase shift oscillator. Phase shift oscillator, which is also phase. Phase means which can generate the 180 degrees. So if it is the output signal which is connected to the input here, you need 360 degrees. But here inbuilt the operational amplifier which can have 180 degrees, and the 3 RC combinations are there. Okay. How many are there? Here you can see that one RC, R and C, another R and C, another R and C. How many resistors are there? 3 resistors. How many capacitors are there? 3 capacitors. So every RC combination which can produce the phase is 60 degrees. How many RC combinations are there? 3. 3 into 60, 180 degrees. So that by this combination 180 degrees, and individually operational amplifier which can have 180 degrees. That's why here the phase shift is total entire is 360 degrees. 360 means 0 degrees centigrade, 0 degrees. So the signal is to be fed back into the output to the input. So here, if it is work as an oscillator, phase shift oscillator, so it is needed here 29. That means amplifier which can have which should be maintained at least to 29 in order of maintain the oscillations. Okay. For a Wayne bridge is 3, that is R1 equals to 2R2. For phase shift oscillator is 29. So when it start the oscillation and A beta equals to 1, that is the case. You can go for it. Next, Colpitt's oscillator. This is the Colpitt's oscillator. Better to remember the circuit diagram. There is a here operational amplifier and inductor is there. Why? Because of this is a lower frequency, radio frequency range, which can produce it. So audible frequency range RC combination is Wayne bridge and phase shift oscillator. Hartley Colpitt's, which is radio frequency range. So here only LC combination which is to be considered here. Okay, C1 and C2, one L is there, inductor is there, operational amplifier is there, op amp is there. So that output, how it is to be getting here, you can easily guess that. So you have to do the calculation part, and you should remember this. Next, Hartley oscillator. So here, which is also consist of here a capacitor and inductors here. So the output voltage which is connected to the inductor and voltage across L1 is to be feedback into the voltage. So this is the case here. How many inductors are there? Two L's are there. L1 and L2, 2 inductors are there. And a capacitor is only one capacitor is to be considered here. In Colpitt's, only 2 capacitors and only 1 inductor. Hartley, 2 inductors, 1 capacitor. Okay, opposite to that. So what is the condition? A equals to 1 by beta is the condition. That means A beta equals to 1. So in practical, Hartley oscillator is a single inductance coil which is to be used with the tapping instead of L1 and L2. Okay, what is the summary? Using a feedback circuit and amplifier which can convert into an oscillator, and Barkhausen criteria A beta equals to 1, which is very, very important for a general oscillator arrangement. So the loop gain, which is the produce of the open loop gain of the amplifier A, and the feedback ratio is beta. And here LC combination as well as the RC combination. LC to produce the audio frequencies, LC is very difficult. And that's why you are using a RC combination, Wayne bridge and phase shift oscillator. LC, which can produce higher frequencies, radio frequencies, than the R and C combination compared to that. So in this case, Hartley and Colpitt's. Okay, in Colpitt's only 1 inductor, 2 capacitors, and in Hartley 2 inductors and only 1 capacitor, along with the operational amplifier is to be considered. Next, multivibrator. So there are what is the interaction of the multivibrator? Multivibrator, which is also known as a relaxation oscillator. and also non-sinusoidal oscillator. Okay, what is that? Non-sinusoidal. You can produce this sinusoidal means which can give the output as a sine wave. So that here which is a non-sinusoidal oscillator, multivibrator, and also which is to be consist of a two-stage RC coupled amplifier with the output of each stage which is coupled to the input of the other one. So that's why you have to say that this is nothing but a two-stage RC coupled amplifier. Well, somewhat you have to remember that at input, if you give by using the RC combination, which is a 2 volts, which can here gives the RC combination is 4 volts output. Again, that 4 volts output, which is connected to the input to the other RC combination by using the coupling capacitor C. So that is again fed back to the RC combination, which can gives the 7 or 8 voltage. That means by using the different stages using only RC, you can easily enhance the voltage or current, whatever it may. That is the advantage of the RC coupled amp. So here, what is that? The condition for the multivibrator, which is to be remain indefinitely in the same state, then the current is to be triggered by the external signal, which is known as a stable state. Okay, so multivibrators which can perform a variety of useful functions like which can generate a square wave waveform for counting as well as the frequency division as well as the generation of the time delays, etc. The multivibrators which can divide it into 3 categories. One is that a stable multivibrator, another is the monostable. Mono means single, bistable means 2 stages. Okay, a stable multivibrator. What is a stable multivibrator? Which is a multivibrator which is neither state in a stable. Okay, so there are 2 temporary states are there. 2 temporary states you can call it as a quasi-stable states. So the circuit which can change the state continuously from one quasi-stable to the another quasi-stable state within the same regular interval of time without any triggering. Okay, so which can generate a continuous square waveform in the case of a stable. Monostable. What is monostable multivibrator? Which is a one-shot multivibrator which can have only one state, and when the pulse which is to be applied to the input, the circuit state is changed abruptly to unstable state for a predetermined time, after which the circuit is returned to original stable state automatically. Okay, and also next one is the bistable. Bi means 2. Okay, so this is also known as a flip-flop. What is a flip-flop? Flip-flop is a temporary memory, temporarily it can stores the memory, and also it can stores a 1 bit of information. That is nothing but a flip-flop. So flip-flops are 2 types. One is the RS flip-flop and JK flip-flop. Okay, master slave, D type of flip-flop. So many flip-flops are there. So the thing is that bistable multivibrator, which can have which is nothing but a flip-flop here. That means the memory purpose we are to be using here. So which have 2 stable states, and the circuit which may have a particular state indefinitely, and also hence which can be used to, you can see here, store binary bit of information. Binary bit of information means whether it is a 1 or 0. Okay, when an external trigger is applied, the state of binary which is to be changed here. At the occurrence of each triggering pulse, the circuit state changes abruptly from one state to the another state. So this is used as a digital memory device by stable multivibrator. A stable multivibrator you can see here. So a coupling capacitor is there. How many resistors are there? 4 resistors are there plus VCC, and 2 transistors are there, T1 and T2, and which is to be connected through the input. We are to be giving to the transistor T1, and the output which is fed back into the input of the other state, other transistor, by using the coupling capacitor. Where is the coupling capacitor? See here. C1 is a coupling capacitor, another C2 is another coupling capacitor, like that. Okay. So these are the stable multivibrator. So you have to write down from that what is to be going on, explain. So it is to be generating a square wave. You can see here square wave. This is the shape of the square wave. Here ones and zeros with respect to the bit of information here, digital bits. So ones and zero. One means high, high means on here. Zero means off, off means low bit here. Okay. Vertical position it is to be showing that here on condition, and horizontal position which is to be showing that a off condition, high and low, high or low, like that. Monostable multivibrator. Mono means only single, quasi-stable. So here also two transistors are there. A capacitor, coupling capacitor, and there are two coupling capacitors are there. A resistor is to be considered here. About these, you have to write it down. 6A here. Bistable. Only no capacitor is to be considered in the case of a bistable. Why? Because of it is to be act like a flip-flops here. It can store the one bit of information temporarily. Okay. So that's what here no capacitors are there. Only everywhere you have to be considered here resistors and only T1 and T2 transistors are there. So when T1 is off and T2 is on, another one is the T2 is off, T1 is on, how the conditions is to be takes place. Next, Schmitt trigger. Schmitt trigger is this one. This is the case here. A sine wave is there when it is fed back into the transistor, and the output which is to be generating a square wave, Schmitt trigger. You can see here. Sine wave signal is to be passing through that. It is to be generating a square wave. Schmitt trigger. See here. This figure is also important. When the on condition is to be takes place, when the off condition is to be takes place, that is to be considered. So the non-sinusoidal oscillators like a stable multivibrator and for a timing signal, a monostable can be used for a frequency division or a delay producing circuit. A Schmitt trigger is useful for as a squaring circuit. That means which can convert say giving non-square wave input like into a square wave. What are the questions? Explain and working of a stable multivibrator, or else a monostable multivibrator, or else a bistable multivibrator. Out of these three, one question is to be given. Short question is Schmitt trigger. Last. Next, power supply and regulation. So in this, you have a rectifier and filter, voltage regulation, and functioning of CRO, cathode ray oscillator. See here, what is rectifier? A rectifier is a junction diode which can convert the here AC into a DC, pulsating AC into a DC. Before that, we have been discussed that an oscillator which can convert the DC into AC, whereas rectifier which can convert the AC into DC. A PN junction diode is the best example for the rectifier. Next, halfway rectifier. So here in this halfway rectifier, here we are using only one single diode. So in this only we are using only single diode half wave rectifier. So AC signal, there is a transformer which is to be utilizing here. In secondary, what is to be happening there? So input by using only one diode. About the diode, you have to know about that in forward bias the diode which is to be conduct the current. In reverse bias the diode is not going to be conducting the current. So by applying the same principle here in forward bias, that means forward and reverse means here the sine wave which includes the positive half cycle as well as the negative half cycle. When it is fed back into the diode here, the signal is to be generated. The negative half cycle which doesn't allow, that means in reverse bias, the diode is not going to be conduct current at all here. That means here 0 to pi, the diode is to be conducting. Whereas in pi to 2 pi, the diode which is negative half cycles, the diode is not going to be conduct any current at all. That's why only half wave which is to be considered. And also here we have to calculate that what is the efficiency of the half wave rectifier. So only 40% and compared to that of the full wave rectifier. Okay. So here you can see that here full wave rectifier which consists of two diodes. Okay. D1 and D2. So if one diode is in forward bias, another diode is in reverse bias. Like that, vice versa, which is to be changing here. The continuous waveform which is to be generating here. That means which can convert the AC, okay, AC into a DC here, whether it is a voltage or current, whatever it may be. So some pulses, AC pulses is also to be carried out along with the DC in output section. The dotted line which is to be indicating that AC here, what is that ripples which is to be generating here. Okay, now. So here, how do you remove these ripples? Okay, by using a filters, you can easily remove that. That means here the efficiency and also whatever maybe here this is the bridge rectifier, and how to remove these ripples here. So we have to use a filters here, filter which is to be removing the ripples here, which is carried out by the here in half wave as well as the full wave. So here L type filter is there. So here you can have see that here what is L type L section filter is there. So how it is to be removing the here ripples of along with the output wave here, you can easily see that. And also pi filter is also there. L and C combination, which is nothing but a pi filter. By using the filters, you can easily remove those. Next, a voltage regulator. How the voltage regulation, Zener diode is a regulator, how it is to be utilizing here. And here uh, switch mode power supply SMPS. Okay, switch mode power supply, how it is to be using as a switching regulator here. So many times this question is to be asking. Zener diode, Zener is regulation, and also shunt regulator you can have here. Okay, Zener voltage regulator here. A battery it is to be utilizing, a Zener diode, a resistor is there, and load resistor, and what is the load voltage, how the voltage is to be regularized by using the GNR diode. Okay, input which is a variable voltage, and output how the voltage is to be regulated here. That is possible by using the GNR diode. Okay, so GNR diode which is a best example for the PN junction diode. Here also how the regulation is to be takes place. You have to do that calculation part also, equation part also. Next one is that fixed voltage regulator. These are the short questions. You can go for that. SMPS. Yes, you can have. This is also so many times asked as a short question here. Switch mode power supply, SMPS. Okay. So this, and final one is the CRO. What is CRO? Cathode ray oscilloscope. Working, and here there's so many times this is to be asked as an essay question here. How the CRO which is to be takes place, how it is working here. Now, what are the plates, X plates, what is the Y plates here, how the magnetic bars is to be here keeping out there, what is the triggering circuit, what is the time-based generator here, horizontal amplifier, delay line here, and also very well here, what is the amplifier here. Okay, how the electron gun which is to be projecting the electrons toward the screen, CRT, cathode ray tube. Oscillator is different than the here tube here. On the picture only that you can easily observe that how the electrons which is to be projected by the electron gun. Okay, so each and every skill uh, uh, point you have to explain in terms of the what is a vertical amplifier, what is the working here, what is CRT, what is time based generator, how the electrons are projected on the screen, what is the screen here, what is electron beam here. A beam, electron beam means which can continuously give the send the electrons here. And what is the vertical plates, what is power supply, triggering circuit here, horizontal amplifier, electron gun, horizontal plate, input signal. So each and every point you have to write it down in your words. Okay. So this is about the CRT here. So this is asked as a essay question CRT. So this ends our DSC syllabus here. That is the basic electronics. Okay. So you can go for there are 4 units, each and every unit you can have two questions. That is for essay, and short is also to be available. In this meanwhile, if you have any doubt regarding this paper, you can call me at any time at any cost. Okay. All the best. Right.